All right, welcome to Stewart Section 2.3. We're going to calculate limits algebraically instead of just typing things into the calculator. So the first thing is limit of a constant. So if we say the limit as x goes to 5 of 7 is equal to what? Well, that's your function right there. That's the function. The function is 7. Well, what is the function 7 about? That's the function y equals 7. It's a constant function. It's always 7. So it doesn't even matter where you go to. I just picked 5. The limit of a constant is the constant. So the answer is 7. So the limit as x approaches a, just some number of c is equal to c. So the limit of a constant is a constant. Plug it in, plug it in. X goes to 2 on 3x plus 8. So that's a line, right? And we're going to 2. Just plug it in. So it's 3 times 2 plus 8. I think that's 14. Ba-boom, done. Factor. So we saw this one the other day. We saw limit x goes to 3, x plus 3, oh, no, that was on the, excuse me, that was on the bottom. So I need to get rid of that. So x squared minus 9. And then x minus 3. So when you plug 3 in, you get 0 over 0. But you can get an answer to this because you factor. So you say limit as x goes to 3, you get x plus 3, x minus 3, x minus 3, and then the problem goes away. That's what was causing the problem in the division of 0 and all that stuff. But this is left now. Plug the 3 in, plug it in, and you get 3 plus 3, so the answer is 6. So that's a repeat of what we saw before. Crazy factoring. There are factoring patterns that you may have don't remember running into or not. A cubed plus b cubed is the sum of two cubes. That's a plus b times the quantity a squared minus ab plus b squared. That's the sum of two cubes. That's a factoring pattern. So you got to recognize something like x cubed plus 8. 8's a perfect cube. X cubed is a perfect cube. So you have x cubed plus 8 is equal to x plus 2, right? It's the a and the b, or the 2 is being cubed and the x is being cubed. X squared, and then a times b would be 2x, and then b is 2 because 2 cubed is 8, so it would be plus 4. Similarly, a cubed minus b cubed is another factoring pattern, so it's a minus b, and then it's a squared plus ab plus b squared. Sometimes these just show up from time to time, making you aware of them. Things like this show up as well. X to the fourth minus 16 is the difference of two perfect squares. So you get x squared plus 16, and then, or 4, not 16, 4. 4. And then x squared minus 4. And then you're like, oh, it's the difference of two perfect squares again. So it's x squared plus 4, and then x plus 2, and then x minus 2. So that kind of stuff happens. Okay, rationalizing the numerator instead of rationalizing the denominator. If you put 0 in here, you get 0 over 0 again. So we're going to rationalize the numerator. So we're going to multiply by the conjugate. So we're going to do the square root of x plus 4 plus 2. And then do the same thing on the bottom. Square root of x plus 4 plus 2. All right, so make this all fancy. So the middle term is going to cancel out. That's the whole point of this. So this times this is x plus 4. This times this is 2 of the square roots. That times that's minus 2 of the square roots. They cancel out. This times this is minus 4. Well, minus 4 and plus 4 become just 4. So we got limit, limit x goes to 0, and then now I have limit x goes to 0, and then I got just an x on the top. Don't multiply this out, just leave it. So it's x times the square root of x plus 4 plus 2. Well, then look, you can see what happens here. Now, I should have written this right here. Okay, so then that cancels out. There's a 1 left there, right? Now you can plug it in, because the division of 0 is gone, because that x went away. So put 0 in there, and that's square root of 4, which is 2, and then plus 2 is 4, and then there's that 1 on the top, so the answer is 1/4. 1/4. All right, simplifying. So we're going to square this out. We're going to get 4. Well, when you square binomial, you have to write it down twice, right? So it's at 4 plus h, 4 plus h. So we get 16 plus 4h, and 4h makes 8h, plus h squared minus 16 over h. And it's the limit as h goes to 0. Now see, the 16s go away, and then the h divides out. So we get the limit as h goes to 0. See, the issue's gone. The h's divide out, and you have 8 plus h. So the answer is 8. Knowledge of functions helps you solve limits. So this is e to the x. What do we know about e to the x? It's an exponential function. It goes through 0, 1. Well, if you're going to negative infinity, what's it doing? It's heading towards 0. Sine. Sine is a mountain, a valley, a mountain, a valley, a mountain, a valley, right? It goes back and forth forever. So when you go to infinity, you don't know whether it's up or down or whatever. So it just keeps going back and forth, back and forth. So it fails due to oscillation. So it does not exist on that limit. All right, 3 to 31, odd. Go for it.